Okay, so welcome to the last class. I hope you can see, maybe it's not very nice, but it's reasonable, is it? I hope so. So, Assalamu alaikum. Welcome to the last lecture of the week. I hope you finish very quickly because these are only 4 slides. And basically, we're just looking at examples from this, okay? Evaluating, finding the logarithm of complex numbers. So, we were looking at the last one here, which is just talking about the natural log of minus 1 minus I. This is z equals that, okay? So basically here again, ladies and gentlemen, what do we have? Well, this is x equals minus 1, y is minus 1. So what do we have? Z, x is minus 1, y is minus 1. This is in the third quadrant. You have the quadrants are like this. First, second, third quadrant is here. Between 180 and 270. That's the third quadrant. So that means that's where it is. So basically that line like this. So 45 degrees, but in the third quadrant will mean that you go 180 degrees plus 45, which will give you, 180 is how many? 45 4 times, then you add one more, it becomes 5. So basically the argument tan theta minus 1 over minus 1 is 1. It means the argument will just be 5 pi over 4. How did I get 5 pi over 4? So it's 180, then I go to the third quadrant, 45 degrees. So 180 basically has 45. So 45, 45, 45, 45 4 times is 180 plus 45 will give me this. Those are 5 of them. So that's now the logarithm of ln of minus 1 minus I will be log to base e modulus of this plus I, the argument which is 5 pi over 4 plus 2 pi k. And then now this one, basically the modulus is just this square plus this square root. So it's 1 plus 1 square root, which is root 2. So it's log to base e of root 2 plus I 5 pi over 4 plus 2 pi k, or this. You can leave it the answer like this, or you can leave it this way. You don't need to compute this. You can just leave it like that. That's that, ladies and gentlemen. We're just using a formula. There's not much. Okay, third example is saying you find all the values for e raised to z equals root 3 plus I. So basically here now you just need to remember, what do you need to remember? E raised to z equals root 3 plus I. This is equivalent to, if I apply ln to both sides, this will be ln, so it will just be z equals to ln of this number. So we just go back to the same thing we've been doing. So now the ln of this will just be log to base e of modulus of this plus I argument of this 2 pi k. That's it. So x is root 3, y is 1, so tan theta equals 1 over root 3. Now, this reminds you a nice way of remembering. So 1 over root 3, now this is a repetition, I should not have put it. 1 over root 3 is the same as 1 over 2 divided by root 3 over 2. I just multiply by a half. Because now this corresponds to sine, this corresponds to cosine. So the angle whose sine is a half is 30 degrees, which is pi over 6. And so we have pi over 6. The same, root 3 over 2, cosine of root 3 over 2 is cosine of, the same angle, so it will be pi over 6. So z, which is this, ln, so log to base c of modulus of that plus I, pi over 6, 2 pi k. And so we just have log to base e of 2, this is root 3, squared is 3, plus 1 is 4, square root is 2, plus I, pi over 6, 2 pi k. You can leave it like this, or you can use your calculator to get the answer. We are done. Okay? Now, we just have a few more slides. This is 16, 17, 18. Okay, not bad. We're almost done. So the fourth example, example number 4 says, find the principal values of ln of z. So basically now I'll take you back, ladies and gentlemen. Here we were looking at natural log of z. Now we're looking at the principal natural logarithm. So the difference is here. We throw away this, we just use the argument, the principal argument. Basically theta that lies between minus pi and pi. Okay? So it's the same thing we've done. All we'll do for all the examples, we will just replace the answers we got, this part, with the principal argument. So I take you back. The first example here, we have, this is what we found. So we replace this with the principal argument of z. And pi over 2 is 90 degrees. 90 degrees lies between minus 180 and 180. So we just replace this with I pi over 2. So it will just be I pi over 2. Look at this. So z equals minus 2. We have the principal natural logarithm will be log to base c modulus of that plus I, the principal argument of z. We've already said principal argument is, I gave you the wrong one. That was the second one. The first one was pi, sorry. It's pi. So it should be pi here. So we just have log 2 base e of 2 plus pi I. That's it. Next, the same thing we did previously, we just replace. So we have ln of I will be log 2 base e modulus of I plus I, principal argument of I. Principal argument of I is pi over 2. Why did I write this? This is a mistake, ladies and gentlemen. What happened here? This is it. Yeah, this is what we have. Pi over 2. So this we just cover that. So it will just be log 2 base e I, so which is 0. So it will just be 0 plus pi I over 2. This should be, where is it? So this is 0 plus I pi over 2. So this should be pi over 2. So this is pi over 2. I'm sorry, this I will correct, but this is pi over 2. And lastly, we have z equals minus 1 minus I. Well, now here we had the angle we had previously. Let me take you back. Is this one? Where is that? Here. The angle we had is 5 pi over 4. You see, we had 180 plus 45 degrees. Now that already is bigger than 180. We are supposed to have minus 180 to 180. So now we go the other direction. You see, when you are in third quadrant, we can start from 0. We measure the other direction this way. So it will be, you can think of it as 360 minus this angle. Or you can go negative direction. You just go, now you are here, third quadrant. It's basically where now? 270, you remove 45. So 270 to 360, that's 90. So it's basically 245, 45, and then 45. So it's minus 3 pi over 4. I hope it makes sense. Minus 3 pi over 4. So this angle is the same as this angle, only that this one now is a principal one. Minus pi over 4, what is that? Is minus 135 degrees. So that lies between minus 180 and 180. So it's a principal argument. And therefore, the solution is just log 2 base e of root 2 plus I minus 3 pi over 4. And that's it. Okay, ladies and gentlemen, now we just have 2 more slides, which I hope the camera is recording because now it might be tired. Anyway, I'm getting hot. So, suppose z1 equals 1, z2 equals minus 1. This is supposed to be minus 1. Find ln of z1, z2, multiply ln of z1 over z2. Now, ln of z1 times z2 is the same as ln of z1 plus ln of z2. Now, we already know ln of 1 is log 2 base c of 1 plus I argument of 1 plus log 2 base c, this is supposed to be modulus of 1, but then this is supposed to be modulus also, plus I argument of minus 1. Now, log of 1 is just 0, so this is 0 and this is 0. The argument of 1, what is the argument of 1? 1 is a constant, x equals 0, so it's just be 360 degrees, okay? It's 2 pi, and then the argument of minus 1 is pi. So this corresponds to cosine when cosine is minus 1, when cosine is 1 for this one. So it's 2 pi plus pi I equals 3 pi I. And then now for this one is just the difference. 2 pi I minus pi I, which is pi I. I hope it makes sense. If it doesn't, you will tell me. Because I want to finish now the last slide here about complex powers. I wonder whether it's supposed to be here now. Okay, so for alpha in C, for a complex number alpha, then z raised to alpha is the same as E alpha ln of z. So here I put a remark to say that to see this, just apply natural logarithm to both sides, you will get equality. In other words, if I take natural log here, I'll have alpha equals ln of, if I put ln, this disappears. So alpha ln of z. Okay? If I cover this, I call it y. I take ln, I'll get ln of y equals alpha ln of z, which is alpha ln of z. Okay? So this is a definition, that's all you need to remember. So if I give you an example, determine the value of I raised to 2 pi I. These are complex powers now that you have been finding. So how do you go about that? Well, you will just say that, so you need to identify z and alpha. So z is the base, so z is I, and then the power is alpha. And then, so now to get I raised to 2I, how do you evaluate? So it will be E raised to 2I ln of I. Now, this is just E raised to 2I, ln of I is log 2 base C of the modulus of 1 of I plus I argument of I, brackets there. So this will just be e raised to 2I times, this is 0 by the way, I don't know why we're carrying it. Then this is I, argument of I corresponds to 90 degrees pi over 2. So it's pi over 2 over 2 pi k. So this is 0, so it just be e raised to 2I into brackets I pi over 2 plus 2 pi k. If this I goes inside, it becomes minus, so you have this minus. Then this 2 cancels out. And then this 2 multiplies this 2, so you'll have e raised to minus pi. This 2 cancelling, the pi going out, so this is 1, and this is 4k. Okay, that's it. Ladies and gentlemen, that's the end of this week. So all the best. Let's see how it goes.